Hey folks, I do have a video on how to do a scatter plot on a graphing calculator, and it talks about scatter plots as well. But this video is just basically strictly about scatter plots and understanding them, but also learning how to make them on a piece of paper. And yeah, we're not going to focus on the graphing calculator in this video. So a scatter plot is really a graph of ordered pairs. And remember, ordered pairs, if we have, well, just watch the video on the Cartesian plane that I have. That explains ordered pairs. And it shows the relationship between those, between two things. One is independent and one is dependent. So I'm going to draw a little graph here. This is just the first quadrant, as I said in the Cartesian plane video. This is just the first quadrant we're going to look at here, and they could give you an ordered pair. Let's say it was 3, 4. That is an ordered pair, and you would plot it 1, 2, 3. Remember, this is the x-axis, this is the x-axis, and this is the y-axis, and the 4. So 3 across and 4 up. 1, 2, 3, 4, and you'd plot a point. You could label it as 3, 4 right here. But anyway, a scatter plot is when you have a whole bunch of these plotted points, and there could be many, many different situations where you have this is the dependent part, the y-axis is the dependent part, and down here is the independent part. So, for example, your mark on a test may have a very close relationship with the amount of time that you studied. Okay? So this part would depend a lot on this part here. Okay? Studying doesn't depend on your mark. It's the other way around. Your mark would depend on how much you studied. Okay? And that's why studying would be the independent part. And over here is the dependent part. Anyway, so what we're going to do is look at scatter plots. If there was a class and if you saw that their dots, their scatter plot looked something like this, and there might be somebody down here, somebody who got a very high mark. The people that didn't study as much would be the people down here on this side, and the people that did study more were the people on the right side. And the further you go, you notice it kind of looks like there is a general trend here, okay? And it seems as though the more that you study, the higher the mark that you do get. There are people that don't fit that mold, like this person and this person here, and those people, they are called outliers. Okay, those plotted points that are not quite fitting the norm are called outliers, just so you know. All right, well, let's keep going through this. So basically, here's another situation. Here's a scatter plot, and it seems that it's taking place at a beach, and the number of visitors on the beach seem to depend on the average daily temperature. So just like the last example I showed you, this scatter plot shows that the higher the temperature, it seems the more people were visiting that beach. And just like before, this is an outlier right here. There were not many people visiting on that day, even though the temperature was high. Okay? But the general trend seems to be like this. And this line here is really a line that kind of cuts through the majority of the dots. It cuts through and shows the general trend. A straight line like this is called a line of best fit. Okay? If this data here was curved, and there are scatter plots that have a curve to them, as we'll see, those are called the curve of best fit. Okay? But anyway, so the trend here, I put these words on the side just to talk about them. The trend is that the higher the temperature, it seems the more visitors there were. Would you agree with me? If you want, you can push pause and just have a proper look at this, just to see if you agree with me. As far as positive or negative, well, this is a positive trend. It's a positive line here. It's moving upwards from left to right. A negative would be going downhill from left to right. It would be going downhill. And there are scatter plots that go downhill. Okay? It could be the other way around. The hotter the temperature, the less people go to a ski hill. If I was to write ski hill here, well, There's not a lot of snow at any of these temperatures, so maybe that isn't a good example. But anyway, the warmer the weather, the less people that would be going to a ski hill potentially, especially if there's no snow. I'm from Canada, so yeah, we sometimes can have fairly warm weather if you go high enough in the mountains and still have snow, but that's a whole nother thing. Linear or nonlinear? Well, remember, linear has the word line in it, and that means it's a straight line. Nonlinear means it's a curve. Okay? Strength, that has to do with how close are these dots kind of moving along together. And I would say this one's pretty strong. The points, the plotted points, are staying quite closely around this line that I just drew here. So the strength is pretty strong. If there were a lot of points kind of like this outlier here, like that, if there were lots like that, I'd say it's a weak positive, relationship here. But in this case, it was strong. Okay? Hopefully those words are all making sense to you. So when you look at this one, speaking of a weak relation, I would say possibly it looks like there might be a relationship where they're moving in this direction. Might be my imagination, but I would say the strength is weak. I'd say it's weak, but it is positive. It is going upwards, and that's just how I'm feeling about this. Sometimes it's based on your opinion, but you'd have to argue it with the teacher, and hopefully they would be okay with you if you really didn't understand or you really didn't see that these were moving in a positive direction. Now this one here is harder to argue with because we can see that things are moving pretty tightly packed, moving downwards here, okay? So it's strong. They're very tightly packed together, but they're not moving positive, they're moving negative, which means going downwards from left to right. If you were to write your name along here, it would be going downhill. Now this one here, to be honest, I don't see a correlation at all, or sorry, a relation. The word correlation is sometimes used, but don't worry about that right now. If you don't need to know that word, that's fine. There seems to be no relation here or correlation. It seems to be pretty random. So I'm not able to say if these are moving positive or negative or if they are strong or weak. So I would just say it's weak, and I don't know if it's positive or negative. I don't know if there's a relation. Okay, I would put a question mark whether or not there's a relation. For example, if it was, what's the relationship between your favorite hockey team and whether whether they win and whether it's raining outside? It may not have anything to do with each other because hockey is generally played indoors on an ice surface. So anyway, that would be a weak relation, and maybe none at all, maybe no relation whatsoever. Okay, and you can't really talk about the strength of it other than that it's weak or non-existent. Okay, let's move on. Is there a relation here? It seems like there is here. This one is based on electricity used and the energy efficiency of an appliance. Okay, it seems to me I would draw kind of a line moving somewhat like this. So it seems like there is a relationship here. And if you wanted to describe the relationship, the more energy efficient, the less energy is being used. So the more that the appliance is good on energy, in other words, uses less energy, the less electricity is used. So maybe you could say, well, the less money you're also spending on your bill, okay? Because hopefully the appliance that you have is energy efficient, okay? That's a good thing. So that's the relationship I would write here. If I had the ability to write neatly, I would write something like, the more energy efficient the appliance, the less energy is used. I guess that's common sense, but I had to write it anyway. The next one. Well, this is obviously the height of a ball over time. So maybe at the beginning it's thrown from maybe a small cliff or a small hill. It's thrown and it goes down a little bit lower. Okay, the ball seems to go a little bit lower than it started. The height was lower. Maybe it went into water. Maybe this is water right here. and the ball kind of sunk into the water. That's maybe more likely. And time always increases. We can't really make time go backwards. So the height of the ball depends on the time here. And when the person threw it, it went up, and then it hung here, and then it fell down. And if we were to draw a line of best fit, we wouldn't really call it a line of best fit. We'd call it a curve of best fit. And it would be quite simple to just connect these dots and show that curve. In math, there's a special name for this kind of curve. It's called a parabola. It's really cool. You can learn about it in other videos that I have. But for now, you just have to know that, yes, there is a relationship between the height of the ball and time. And, I don't know, how would you describe the relationship? You might have better words for this than me because I'm just going off the top of my head. But the height of the ball depended on the time. And it also depended on someone throwing it. But as far as the height of the ball, you can see that it went higher and higher, and then gravity took over and brought it back downwards again, as gravity tends to do to everything. Okay? So that is basically the relationship between those two. And generally, you don't see scatter plots like this. Usually we have lines that are drawn rather than just dots. But technically, that was a scatter plot, I guess. In summary, to create a scatter plot, all you have to do is create a graph. Make sure you label it, okay? Notice how these two graphs had labels here. It would be good if there was a title here too. There'd be some kind of title. Energy efficiency or energy usage would be at the top. And then over here you have a label here and another label here. So this is called a title when you put something up here. And over here are called labels. And it's also sometimes good to have numbers or a scale on the x-axis and the y-axis. All right. And when you do a scale, make sure there's units. So, energy efficiency could be in kilowatts. The time. Well, here the time was in seconds, and the height of the ball was in meters. Okay, so those are units right there. So these scatter plots here could have had a scale put on them. But these are things to think about when you are making your own scatter plot, okay? And sometimes you don't need graph paper. Sometimes you can just go like this, write in your title, write in your labels, and do a scale. If the scale doesn't start at 0, sometimes you can even put like a break in the graph and start with, let's say it starts with like 100 right here. And then it goes, I don't know, 120. 140. This break right here means we're starting right at 100. We don't have to waste a lot of space. Okay, so your teacher may sometimes show you a break drawn there or here. Okay, I think I've said enough. I think you have an idea what a scatter plot is now, and hopefully you can take it from here when it comes to what kind of homework your teacher may have given you to work on. Good luck with that, and I will leave you. Have a great day.